Hi everyone, welcome back to the next video in our video tutorial series. In this video, we're going to be looking at the week 5 tutorial question 3, which is going to involve essentially calculating a confidence interval for the means. Okay, so let's have a look at this question. Okay, so in this question, we've been told that one might expect that a larger floor area would indicate a house has more bedrooms. But is it the case for the Perth housing data set? Okay. So this tends to stand to reason, right? As a house gets larger and larger in terms of its floor area, um, makes sense that it's probably going to be a house that has more bedrooms because it's taking up more space. The bedrooms themselves take up more space. So we should expect to see some kind of relationship between the number of bedrooms and the floor area here, right? What we've been asked to do is we've been asked to group the data by the number of bedrooms. So we see at the moment we've got our data, just our bedrooms column and the floor area, and we've been asked to group the data according to all the bedrooms or all the houses that have 2 bedrooms, all the houses that have 3, 4, so on. And for each of those number of bedrooms, we're going to calculate a confidence interval for their like floor area. Okay. Using these confidence intervals, we're gonna try and interpret what these intervals are and what they can say about if there's any statistical difference between houses with different numbers of bedrooms and their population floor area. Okay. So the easiest way to do this in terms of grouping the data uh, in in this way is to make some different headings here. Essentially grouping it by the number of bedrooms. So I'm going to start by writing out bedrooms, and I'm going to give them some headings that basically just indicate, how many bedrooms are in each of these houses. So I'm going to go 2, 3, 4, and then for my last category here, I'm just going to go the house has 5 or more. Okay, so I'm going to go 5 plus to basically indicate that. If we want to group the data according to some condition, what we're essentially doing is we're filtering through the entire data range until we've only found the particular observations we care about that meet some condition. If we're doing this, a function that's going to be very useful for us is the filter function. Okay. The filter function allows us to specify some array of values that we want to go through and filter, and then also some condition that is going to be enforced to actually do the filtering. Okay. So the way we use this function, we'll go equals filter. We'll do it over our range here for the floor area. And our condition is that the number of bedrooms has to be equal to whatever heading we've given it here. So it has to be equal to 2. That's going to equal the number of bedrooms here. Okay. I'm going to lock in place my range here for the number of bedrooms and also for the floor area. Okay, let's troubleshoot this a little bit. The ranges here need to be the same. It looks like I didn't go down to the same point. That needs to be to 442. All right. Because we've locked it in place in the number of bedrooms and for the floor area, we can drag this across. And we'll notice when we get to this 5 plus category, this isn't really something that we can say, is it equal to 5 plus? It's interpreting that 5 plus as being a string. So it's not able to do this comparison here in terms of the equals. So what we need to do is just manually change this so that we're just testing if it's greater than or equal to 5. Okay. And there we go. It's able to retrieve the values that we're after. Okay. So the next step here is actually calculating our 95% confidence interval, right? To do this, the easiest way to do this for means is to use data analysis toolpack, which is going to allow us to get our margin of error. And then we can use that margin of error to calculate our lower and our upper side of our interval. So I'm going to start by going to data. Go over here to data analysis and then select descriptive statistics. My input range is going to be this range of values from my headings down. So I'm going to go from 2, select this range here, all the way down to this point. Labels in the first row needs to be selected. The output range, just put it somewhere off to the right or below what we have in our sheet. So I'm going to put this up here. And you're going to want to make sure that summary statistics is selected. That's how we get our mean and other statistics. And our confidence level, this is how we ensure that we get our margin of error being returned. We're told in the question, we're after a 95% confidence interval. So we need to make sure 95% is also written here. When we're happy, we can just hit OK. There we go. We've got our summary statistics here for the floor areas of houses with different numbers of bedrooms. I'm going to do a bit of rearranging for my data set, just because I don't need all of these additional row labels here. And I'm going to want to drag some formulas across the bottom here to get my lower and upper interval. Okay, and it'll be a bit easier if there isn't some text there. Okay, so if we think back in terms of what exactly is a confidence interval is a point estimate, right? Which in this case we could think of that as being x bar. Right, let's see if I can write this out. Right, x bar, and it's plus or minus the margin of error. Okay. The margin of error is composed of your standard deviation, your t statistic, and your sample size. But the benefit of using data analysis toolpack is it's given us this margin of error term. It's just that it calls it the confidence level. Okay. So what we need to do to get our confidence interval is we take our point estimate, which is the sample mean, and we add it and subtract away our margin of error, which is our confidence level. Okay. So that's what we're going to do across our number of bedrooms here. All right. So this is going to be my lower. This is going to be my upper. Lower is going to be my mean minus my confidence level. And my upper is going to be my mean plus my confidence level, or my margin of error. Next, we're just going to drag this across to the right. And there we go. These are our confidence intervals. Okay. So let's have a bit of a think about these. So we can see after calculating these intervals, think about whether the differences are large enough to matter. If the intervals overlap, can we conclude that larger homes typically have more bedrooms? Right? So let's have a look here. Basically what we're looking for here is if the upper side of one of these intervals overlaps with the lower side of the next interval. Okay. So in this case, houses with 2 bedrooms, the upper side of the interval is 210, and the lower side of our next interval is 155. Okay. So what that means is that there's overlap between houses with 2 and 3 bedrooms, which means at a 95% level of confidence, houses with 2 and 3 bedrooms um, we can basically say that we don't have evidence to say that they have different floor areas. Okay. Now, in contrast, houses with 3 bedrooms versus 4 bedrooms, the lower side of the interval here, which is 173, is strictly lower than, sorry, the upper side here of 3 bedrooms, 173, is strictly lower than the lower side here for those with 4. So that means the two intervals don't overlap at all. And that means at a 95% level of confidence, we can say houses with 4 bedrooms have a larger floor area than those with 3. Okay. And again, we can have a look here at those with 5 and more. 206 is strictly less than 219. And those with 5 and more are bigger than any other range here. Okay. So we can say those with 5 or more at a 95% level of confidence have a floor area that's larger than those with 4, 3, or 2 bedrooms. Okay. So what this seems to suggest, as it seems to be generally increasing across the floor areas here, is we have evidence to suggest that the floor area gets larger as houses have more bedrooms. Okay. All right, guys, I'll see you in the next video. Bye.